Hi there, it's me, Mr. B. We're going to add and subtract radicals. Okay, so let's start off with an example like square root of 75 minus square root of 48. All right, step number one, I want to simplify each term if necessary. Well, I'm going to treat square root of 75 as if it's its own simplifying problem. Same thing with the square root of 48. All right, so let's go ahead and do that. Square root of 75 is the square root of 3 times 5 times 5. My index is a 2, so I can circle two 5s, bring one out. So I end up with 5 square root of 3. All right, so for square root of 48, I'm going to have, looks like 2 times 2 times 2 times 2 times 3. My index is a 2, so I'm going to circle groups of 2 of the same thing. So I bring one of each of those 2's out. I'm going to end up with 2 times 2, which is 4, square root of 3. All right, so step number 1 is done. Step number 2, identify like radicals. It's kind of like terms, but instead of dealing with x's and y's and variables, I'm dealing with square roots and cube roots and different kinds of radicals. A like radical has the same index and the same radicand. So if I go up to the top here and I look at what I simplified to, 5 square root of 3 and 4 square root of 3, so I have 5 square root of 3 minus 4 square root of 3. I have the same index, they both have a 2. I have the same radicand, they both have a 3, so they are like radicals. So since they are like radicals, I can go to step number 3. If they weren't like radicals, like let's say that the instead of 4 square root of 3, it was 4 cube root of 3, I would just leave it the way it is, 5 square root of 3 minus 4 cube root of 3. But since these are like radicals, I can now go ahead and go to step 3. All right, so add or subtract the coefficients only. So you're almost going to treat this like it's 5x minus 4x. That would be 1x. So 5 square root of 3 minus 4 square root of 3 is going to be 1 square root of 3. And you don't need to write the 1. And there's your final answer right there. And if you want to check it in this case, you could just type in square root of 75 minus square root of 48 in your calculator, get some crazy decimal, then type square root of 3 in your calculator. That decimal should match. If it does, then you know you did it right. Hi there, it's me, Mr. B. We're going to simplify 3 square root of 12 minus 5 square root of 27. All right, so in order to add and subtract radicals, I need to simplify each term. All right, so let's simplify 3 square root of 12. That's going to be 3 times the square root of 2 times 2 times 3. My index is a 2, so I'm going to circle 2 2's, bring one out. So that's 6 square root of 3. Let's do 5 square root of 27. All right, so I'm going to end up with 5 times the square root of 3 times 3 times 3. My index is a 2, so I'm going to circle a group of 2 3's, bring one out. So I'm going to end up with 5 times 3, which is 15 square root of 3. All right, so for the next step, I'm going to take 6 square root of 3 minus 15 square root of 3. Now before I just go ahead and combine these, I need to make sure that they are like radicals. In order to be like radicals, they have to have the same index and the same radicand. They do have the same index. Both of the index, or the roots here, are 2. They both have the same radicand. They're both a 3, so I'm good to go. I can go ahead and combine these. So 6 square root of 3 minus 15 square root of 3 is going to equal 6 minus 15 is negative 9, and then I just leave the square root of 3 as it is. And there's my final answer. Hi there, it's me, Mr. B. We're going to simplify 7 cube root of 16 plus cube root of 54. So the first thing we need to do is simplify each radical. So let's start with 7 cube root of 16, which is 7 cube root of 2 times 2 times 2 times 2. My index is a 3, so I'm going to circle 3 of the same thing. There's 2's, bring one out, so I end up with 14 cube root of 2. Let's do cube root of 54. So that's the cube root of 2 times 3 times 3 times 3. My index is a 3, so I circle a group of 3 things, bring one out, so 3 cube root of 2. So I end up with 14 cube root of 2 plus 3 cube root of 2. So all I did there was just replace my original radicals with their simplified form. And it looks like I have like radicals. I have the same index and the same radicand. So here's my index right here. They're the same. My radicands are the same. So I can go ahead and add those two radicals together. So now I just add or subtract the coefficients. 14 plus 3, 17. And then just stick the cube root of 2 on the end of it. So 17 cube root of 2 is my final answer. Hi there, it's me, Mr. B. We're going to simplify the quantity 3 plus square root of 2 times the quantity 5 minus square root of 2. Alright, so this problem, when you first look at it, it looks like a FOIL problem. It looks like you're supposed to distribute twice, and that's what you're supposed to do. So it kind of turns into a multiplying and an adding and subtracting problem all rolled into one. Alright, so let's go ahead and do what we know, and that's we're going to distribute the 3 first. So I'm going to take that 3 and distribute it to both of these terms. 3 times 5, 15. 3 times negative square root of 2. So the 3, you can kind of think of it as an outside, as a coefficient. And then you have your square root of 2, that's an inside. You can't really multiply outsides and insides together. All you can do is just stick them together. So I have 3 times negative square root of 2, that's negative 3 square root of 2. Alright, so let's go ahead and distribute the square root of 2. Alright, square root of 2 times 5, similar to what I just did. So it's 5 square root of 2, so positive 5 square root of 2. Alright, now here comes the hard part. I'm going to multiply these radicals together. So positive times a negative is going to give me a negative. Square root of 2 times square root of 2, so if I just write that up here, so if I'm just multiplying radicals, I break down each of the radicals into primes, which they already are, and then I put them all into the same radical. So I move 2 and 2 into the same radical. I'd circle my pairs, bring one out, and I end up with 2. So the square root of 2 times the square root of 2 is 2. And that pattern holds all the time. Square root of 3 times square root of 3 is 3. Square root of 4 times square root of 4 is 4. It's just something that you should learn now because we're going to see it all the time. Alright, so square root of 2 times square root of 2 is just 2. At this point, I can just combine like terms. I have a 15 and a 2. Well, negative 2, 15 minus 2, 13. And then I can combine negative 3 square root of 2 plus 5 square root of 2. And I'm going to add and subtract coefficients since they are like radicals, same index, same radicand. So negative 3 plus 5 is positive 2 square root of 2. Hi there, it's me, Mr. B. We're going to simplify the quantity 7 minus 3 square root of 5 times the quantity 2 minus 4 square root of 5. Alright, very similar to the last example I just did, only in this case, instead of just having a 1 as a coefficient in front of the radical, I now have a 3 and a 4. So it kind of throws a little bit of a tricky part in there, but we'll get to that. Alright, so let's go ahead and distribute the 7. So again, this is a FOIL problem, we're double distributing. So I'm going to distribute the 7, 7 times 2, 14. Now 7 times negative 4 square root of 5 is kind of like 7 times negative 4x. You multiply the coefficients, leave the x where it is. So I'm going to multiply the coefficients here, leave the square root of 5 where it is. So 7 times negative 4, negative 28, square root of 5. Alright, so now I have to distribute the negative 3 square root of 5 to both terms. So negative 3 square root of 5 times 2. Negative 3 times 2 is negative 6 times the square root of 5. Alright, so here comes the hard part. Alright, so I'm going to take this signs, then coefficients, then radicals, and multiply them all together. Alright, negative times a negative, positive. Alright, my sign is out of the way. Now I just multiply coefficients and radicals. 3 times 4 is 12. Square root of 5 times square root of 5 is 5. So I have 12 times 5, which is 60. Alright, so let me show you that in a little simpler way. So 3 square root of 5 times 4 square root of 5. I can multiply them just like we multiplied radicals before. Break the radicands down into primes. They already are, they're 5s. Alright, so I'll multiply the coefficients together, that's 12. Then I'm going to put the 5 and the 5 under the same radical, just like I would have before. Circle my pairs, bring one out. So 12 times 5 is 60. All right, so again, I did coefficients. 3 times 4 is 12. Square root of 5 times square root of 5 is 5. 12 times 5 is 60. That's where the 60 comes from. So you can either do them in your head or you can do them and write them out like that. It doesn't matter as long as you get the right answer. All right, so I'm going to add and subtract like terms. 14 plus 60, 74. Negative 28 square root of 5 minus 6 square root of 5, negative 34 square root of 5.